Rami Krispin from QuantUniversity. It's been a while since we've been doing these guest lecture series. And today, with all the changes in the world we've seen since LLMs have taken over the space of AI, we thought it would be interesting to see a use case on how LLMs could be used for things which you and I probably spent a lot of years trying to understand, which is generating queries. As most of you who have taken a database course have realized, writing queries, the basic queries is pretty easy. But as you get more and more complex and try to kind of join multiple tables and look at various aspects, you start thinking about a database administrator would think about how about understanding the space and building out all the constructs needed. Now with LLMs, this whole task is becoming easier and easier. And I am teaching a course on productionizing AI at Northeastern University. And I thought about giving a student assignment wherein, in case you had all your data in Snowflake, how about we build an interactive tool wherein you could basically interact with your database, not using SQL, but using plain old English language, and wherein you could specify what you're looking for, and basically you go to OpneAI and generate a SQL query associated with the information you're requesting, and then that particular query goes to Snowflake, and then you get back the results. So that was a concept I had, and I structured a whole assignment and gave to my students. And in my research, I found out my good friend Rami was actually writing a package to do the same thing. And then I found out his GitHub repo and thought, well, it would be interesting to kind of, bring that into fruition, not kind of putting together all the bells and whistles and widgets and piping and plumbing ourselves, but leverage a package which he has been working on. Is it in your spare time, Rami, or is this in your official role?
No, that was purely spare time.
Well, I don't know how you get all your spare time. Then I got to know your time management secrets. So we're very fortunate to have Rami Krispin in the audience. So let me kind of do a brief introduction for people who don't know who we are, and then I'm gonna hand over the stage to Rami. So I hope you can see my screen. If you don't, I'm gonna just go back and. So you should be able to see my screen now. Can you?
Yeah.
Okay, perfect. So the topic for today, let me also make sure I record it. So the topic for today is creating a language to SQL generator with large language models. And as Rami was mentioning, he's going to be using a whole package which he's been building in his spare time. But before we go there, just a brief introduction. We are QuantUniversity. We're based out of Boston, Massachusetts, and we run educational programs primarily focused on the financial services and insurance segments. We have been working with professionals for more than a decade now, and we've been looking at various frontier technologies and how do we apply them in practical settings, especially in high-risk environments like financial services. And the approach we take is basically hands-on education. So we focus on building out tooling. That way you not only learn concepts, but you actually enable them by experimenting with that using the QuantUniversity toolbox. And that way you can not only understand concepts, but try it out and make sure that you're not only getting the theoretical value, but also understanding how to implement that in pragmatic sense. Most of the courses we are offering are available online and throughout the world. So we have people from more than 18 countries who have taken our courses. We are partnered with Premier, the CFA Institute, and various other organizations to make these courses available through their audiences. And we offer multiple certification programs. And in case you're interested, just check out the QuantUniversity website to get a feel for various programs. If you are interested in attending a live class, which we're doing in Boston next week. So that's going to be on December the 14th. So we're doing a course on ChatGPT, generative AI, and large language models, risks and opportunities in finance. So this is going to be held on site in Boston at the CFA Boston offices from 8:30 to 4:30 East Coast time. In case you're not able to attend it in person, there's also an option to attend it live over Zoom. So if you're interested, I'll make these slides available, but go to the website and you can register there. In addition, we have a program on machine learning and artificial intelligence risk certificate. We are partnering with Premier to offer this 5-course program. So the goal is to enable people to understand the various facets of risk, but also implementation. And it's a 6-month certification program. And you get professional learning credits with Premier, in case you're going to be enrolling into this program. So with that being said, let's jump to today's guest lecture. So Rami has presented at the QuantUniversity guest lecture series before. So he's a prolific coder and also someone who really knows how to basically take concepts and make them applicable in the professional world. And you can look at his online followers and all the posts he does online. I always learn something new whenever I see his post. So thank you, Rami, for educating the community about all the various cool things he does. And also, he's a prolific R programmer. He's an author, and he's been working on data science for more than a decade or two now. So I would hand over the stage to you, Rami, and help us educate on what new cool things you've been working on and how do we apply large language models to generate SQL code. So you're basically going to be eliminating the whole profession of database administrators through your package, I would presume. So all those people are going to be frantically looking for new jobs, or maybe they'll be using your package to be more efficient database administrators. So take it away, Rami.
Thank you so much. Thank you for the introduction, and thank you for the invite, and thank you everyone for joining today. So just clarified, it's still not a package. It is more a POC. If someone wants to take it to convert it in a package, it should be straightforward. But let me just, I can share my screen and I can dive into the presentation. Can you see my screen? Okay, cool. All right, so today we're going to talk about building a natural language to SQL code generator. Using the OpneAI API. So just a quick introduction. So I'm a senior manager focusing on data science and engineering. I'm mainly focusing on forecasting and MLOps, so that's my bread and butter. I'm by all means not expert on LLM, and I think that's I'm setting here the expectation, or in other words, how easy it was to generate this process with a basic knowledge about LLM, and everybody essentially can go and create it after this tutorial if you have a basic knowledge. I am doing a lot of open source work, mainly in R, but also Python. I'm author of a book about time series, and I'm now working on 2 books, one on time series and another one on Docker for data science. I also have a data science channel in Telegram, so feel free if you're there to join and follow. And again, I want to emphasize that the context of this talk is more related to MLOps rather than LLM, leveraging existing APIs and creating process for generating SQL code. All the material that I'm going to cover today is available. There is a tutorial available on this repo, and also share the presentation before we treat. So sure if you want to share it on the chat or later on. So the agenda for today, we will start with a quick introduction and definition of LLM. We will talk about why we want to create a code generator for SQL, dive into the structure of it, and then review code with the OpenAI, and we will conclude with some next steps or potential next steps. So let's start with what is LLM. So LLM is the process of taking a big amount of data, a text, and train it on some specific models that know to identify relationship between text and predict potential future text. So essentially, if you give some text, that they will run some probabilistic modeling that will predict what could be the text generation that applicable for the text you provide or for a question. And then once you have a model, you can run inference, so you can then ask your question and return receive some text as return. And there is additional concept, which is fine-tuning, which is essentially you're taking existing model, but you retrain it on your own data. And this is mainly related to open source application. So for example, if you taking like a model like Llama or Llama 2, and you have some specific application, you can take your own data, retune, and improve the performance. The main difference between model training and fine-tuning is that the first two steps here are super expensive. Having data, we're talking of typically, like, think about the companies like Google or OpenAI or other companies like Microsoft that they just take the whole internet or big amount of text and train it in models that require large amount of GPUs, and they will train it for a couple of days, and it costs a couple of millions the process, and not every company can do it. So the options here are that either you are taking building solution like the OpenAI and other companies that provide solutions, or if you have the fund, you train the models, or you take open source and fine-tuning it with your own data. Today, we're going to focus on the inference process, so essentially talking with a trained model and getting the results that we are looking for. There is a good talk that was by Andre Carpati, which was released, I believe 2 weeks ago, that really explained the process about how the generating LLM and the future of LLM. So I highly recommend watching it. It's a 1 hour, but it's like other videos that Andre sharing in his YouTube channel, is provide good context for LLM. So with that, let's talk about motivation. Why we want to create a SQL code generator. And think about the typical scenario if you're working in some business environment and you have some database with some information. Let's say you are a company, you are selling products, and all the data about the sales are in some database, and you have some user, non-technical, that come to you as a data science or data engineer with some question. So for example, how many units of product A we sold during 2022 in a specific geo? And either this user is not technical or does not have access for the database, and typically going to be some middle person, which will either be a data engineering or data science that will take this question, write some query, and return the user with some CSV file or some format of data. And essentially, this is it's not a heavy lift. It's a simple questions that it's not a good use of data scientist or data engineers' time. you want that the data engineers will focus on the heavy lifting to build pipelines rather than solving like a simple SQL questions. And this is where, for quite a while, I thought like, when I saw people doing some code generating with the ChatGPT and other LLMs, I thought maybe it's a good use case to build something that the user will send a question to LLM, and the LLM will generate a query and return the data directly to the user. And essentially, the LLM here is a black box, but you can embed it in something like Slack. Slack has a great APIs, and it's a more MLOps operation rather than data science. But that could be a very simple solution. And one of the things that I realized that it's how simple it is to generate this process when I was in the POSIT conference a few months ago in Chicago. And Jeremy Howard from FastAI gave a talk about, it's called the Hacker Guides to Language Models. So it's available on YouTube, so I highly also recommend watching this talk. But he gave a great talk about the landscape of LLM, and one of the examples that took my attention is how simple it is to take a LLM model and generate this process of a SQL code generator. And it shows also example like with a couple of lines of code, you can tune it. So after this talk, it's motivated me to actually go and try and build something like this, to run some proof of concept. And the idea is that if you take, for example, a Slack API, so this is your connection, and on the right side and on the left side, you have the OpenAI, and you want to build something in the middle that connects the two of those APIs and will flow the questions and return the required data. So my approach is to create a Dockerized Python environment that can receive questions, generate a function that generates a prompt, a function that handles the OpenAI API, sending the prompt, returning query, and then sending the query to the database and essentially returning to the user a CSV. So that was the idea. And I was focusing on building the functionality. I want to see first, the question was like, does it really working? Can it something be reliable? And the other question is like, how challenging is to build something like this? So I spent a weekend interacting with both the OpenAI API and also with the Hugging Face API, trying different open source models, and it was really straightforward. The reason that I converged to the OpenAI was performance, both in terms of response speed. The API, you send your prompt, you get a response in between 1 to 2 seconds, as opposed that when you download some LLM, open source LLM on your machine, the inference time is enormous if you don't have some strong GPU on your local machine. Because I don't have a GPU, and I decided to start with something simple, so I went with the OpenAI. So to run this POC, I decided to take some data sets and test it on this data set. So I took the Chicago crimes data sets, which is available on the Chicago data portal. These data sets include 8 million rows and 22 columns, and essentially it's all the crime records in the city of Chicago since 2001. It's it provides a lot of information, like what was essentially any crime that reported, and they generate a record is on this data set, and it provides information like the geographic location, what type of crime, and the result. Was it ended up with arrest or anything else? And to simulate, because I was running it locally, is to simulate the process of speaking with database, I use DuckDB, which essentially it's a tool for speaking with CSV files using SQL. So I use the Python library of DuckDB. I use Pandas to store the data, and the OpneAI Python library to speak with the API. So those are the main prerequisites for this, or the dependency. And here is what I built. So I created a function that essentially building prompt, and I'm going to speak a little bit about the prompt because the prompt is playing a critical role in the success of this process. And then once I generate a prompt that in the structure of the requirements of the OpenAI, I have another function that handle the process of sending the prompt to the OpenAI, parsing the response from the OpenAI API, and essentially give you the SQL query. So before going to the examples, let's talk about briefly about prompt engineering and why it's super important. It's all about the context that you're going to provide. And I found out during this process that the way to think about it is that when you speak with LLM, you should think that you speak with a human. What do I mean? Imagine that simple question: how many cases that related to the Chicago crime? If you want to ask how many cases end up with arrest, so you can go and I went to the web interface of OpenAI and asked this question. So the question was, create a SQL query that counts the number of records that end up with arrest. And you can see that ChatGPT return a SQL query, and generally the SQL is fairly correct, but it would be as correct as you would Google like how to create a query that count numbers. So you see like it's doing select count star as arrest underscore count, generating this variable, and from crime records where arrest equal 1. So here is where it's failed. It failed to understand what is the field name, and it failed to understand the attributes of the arrest field. So in the arrest field name. So in the datasets, the type of this variable is a Boolean. It means it's either true or false, and either it's set as a binary, either 0 and 1. And that's the challenge, right? So if you ask a human the same question, that's more or less the expected answer, which is more theoretical, and you cannot really actually use it in an automate fashion and send it to the database because you're going to get an error. And now let's see if I'm adding a little bit more context. So here I have a table named Chicago Crime with the crime records in Chicago City since 2021. I use a subset. I didn't use all the data sets. The arrest field defined in if the case end up with arrest or not. And it is a Boolean, true or false. And then I ask the same question. And you can see now that I receive a fairly accurate query. I would say that the only thing that the name of the field arrest, it's use uppercase for the A, but I don't think it will change much for SQL. And if I run it, I will get the actual results. So you see how having more context is important. And then, there is the recommendation of OpenAI. There is a structure how you should ask question about SQL. So essentially, you should provide a context about your structure of your data. What is the name of the table, and what are the fields names and their attributes. So essentially, you need to provide the API with a SQL command as you create this table, and this enable the API or the model to understand the context of what type of fields do you have, the names, and what are their attributes. And it will be super important, as you will see later in the next slides. So this is the context. It's here, they call it system, and then there is the user, which is the question, but essentially the system is equivalent to context, and the user is the question that you want to ask. So with that in mind, I created the following function. And what it does, it's take arguments about, you need to provide a table name and the query or the question that you want to ask. And I guess like queries might be misleading. So it's the question the user want to ask. And then I'm creating objects that return the system and the user, which it's the context and the question essentially that as shown in the previous slide. And it's returning also the column names and the columns attributes. And the reason for structuring it like this is for sending it. It's an easier way to communicate with the API with the second function that handle the API. And essentially what it does, as you can see here, it's there is a template which using the same structure as the OpenAI recommendation. So it's asking stating, giving the following SQL table, your job is to write queries giving a user request. And then there is the SQL command create table, and then you need to fill in the table name and the table field. So that's a template, and then there is the user template, which essentially write a SQL query that returns and then add the question of the user. And the following functions are essentially take the table name that provided by the user. I used DuckDB to send a query that that describe the table features, parse the columns names and column type, and fill the system and user templates, and return this object that contains those 4 items: the system, the user, the column names, and their attributes. So essentially, that's a very simple Python function that structure the prompt into the format of the OpenAI template. And then the second function is a simple function that that is wrapper on the previous function and the OpenAI functions that send the GET request to the API. So let's see what we have here. So the arguments, before going to the function, the function receives the following arguments: the API key of the OpenAI, the table name, the query, the type of model you want to use, and some arguments for the model. And again, start by creating a object which returns the message, the API response, and the clean query. And the first thing we are doing is using the previous function. We create the message, and which has two parts, the system and the user. And you can see here the structure of the message is a JSON, has the API requirements, where you have the first role is the system, and the content is the context. And the second component is the user, and the content here is the question the user asks about the data. And then we're using the OpenAI package. We're using the chat completion create function, which essentially this function, what it does is send a text and ask for completion. In this case, we are asking a question, and we are in return expect to get a SQL query. One thing to mention about the parameters here. So I include this function has a lot of parameters, but I include the parameters that I thought that are critical. So for example, temperature. Temperature control the model. It's called temperatures, like the level of randomness. So it's a values between 0 and 1, where essentially if you set it to 0, the model will have a 0 level of randomization of the answer. It will be very deterministic. So anytime you ask, it's like setting a seed. It will return the same answer. And as you set it to closer to 1, the answer could be changed anytime you're running it. So it's going to be random. And leave more room for creativity of the model if you want to refer it as is. Since we are I care more about reproducibility and identify cases where the model answers are either wrong or not wrong. So by default, I set it to 0. I feel like that's the better use case in specifically in this case. You want always to have the same answer because you want to process will be reproducible. And you can control the token and other stuff, but I think that's the most important, the temperature in this case. So let's see example of how the function is working. So I have, again, like the same question I asked before. How many cases end up with arrest? So I create this query, I feed it to this function. And I'm getting the following, so the function returning an object with 3 components, the message, which is the what we send to the API, the SQL, so you can see here, select count star from Chicago_crime, where arrest equal true. And the response is the raw response from the API, is a JSON, which you can see also the full answer here, and you can see like the SQL query as well. Now, if you run it against the table, so we're again like using DuckDB to simulate working with the database, and we send this query, we are getting the right response. Now, I want to run the same question, but adding a little bit increase the level of complexity. So now I'm asking again, like, how many cases end up with arrest between 22 and 23. And you see that the model responds that the model was able to identify year as the corresponding field that to the question when we're asking 2022 to 2023 without providing additional context, and creating the right query. So that's something that I was like really amused about, that it can make the connection between your question and the fields, even if you're not specified, you're not asking between the years 2022 and 2023. So that's a good Krispin, and again, like the context of your fields, how you naming your field is super important for the success of the model. And another question here, summarize the cases by primary type. And again, the model responds to the right query, and you get a summary. It's doing a group by the field, the primary type, and you get the type of assaults. Last but not least, there's another query that I was really surprised to see that I was able to identify, even providing a partial context. So asking how many cases is the type of robbery. And you can see that it was able to identify that when you say the type of referring to the prime type variable and ask the right query. So this conclusion of this process worked really well with simple queries. I limited the POC to a single table. I know that it can do beyond this. It can run joins. If you're providing context about multiple tables, it will run, we'll be able to identify the relationship between tables and run joins. Reproducibility, we talked about the temperature. You want to be able to make this process as reproducible as possible. Cost. So I talked a little bit before about the OpenAI versus the open source. I decided to, I used the paid version. I think that I was able to get to some results after spending 10 cents playing with the API. So it's relatively cheap, but it's for my simple use case. Obviously, if you're a company and you want to do it to scale, this is where you need to think where the trade-off between using the API and paying for it and using your own GPUs and spending the effort of training or tuning a model for your use cases. There is other aspects of privacy, but I think that's a whole different discussion about how you handle the data. And performance. The OpenAI performed really well in terms of both accuracy and also the response time. Here's a couple of next steps. So I want to test other LLMs. So I thought about using the Param 2 from Google. The operation of this process, I talk about Slack, but on the weekend, I saw the integration of the Telegram as a bot, and I love Telegram. So I think that might be my next POC, is to connect this process to Telegram and see if I can run it, create a bot that you can ask questions on top of Telegram. I want to spend more time on the OpenAI Hugging Face API. I need to use some more robust tools that get access to GPUs and see how to do fine tuning. And last but not least, there are other applications that I can think about beyond just querying SQL query. Like think about working with APIs, right? Similar context. Translate equation to a API query. Visualization, like you ask for data and now you want to also to visualize it. You want to do forecast and so on. So I feel the sky is the limit. Like you can do so much with this. It's just the beginning. The application are there. Here are some resources that I use for, I talked about and use for this. So you have the code, as I mentioned, in my repo under link to SQL repository. There is a link for the Jeremy Howard talk and the notebook on this talk. There is the link for the Andrei Karpathy talk about the introduction to LLM. And I also linked the OpenAI example for format for SQL prompt. With that, I will pause for questions if there are any. Happy to answer.
Yeah, thank you so much, Rami. This was an excellent tutorial. I would love to kind of play around with that, and thanks for sharing the GitHub link so people can play around with it too. A couple of questions just comes out of the bat. One, how do you kind of handle schemas when you had like a database which you already knew? So I'm trying to think, like, in case there are multiple tables, like what amount of knowledge should the end user have with respect to the schemas, and how should they be able to educate the engine about here's what the data looks like, and this is what we want um, the query to be generated? Or do you just expect that the end user assumes that the behind the scenes, the schemas will all be parsed out or hashed out for them to get the answers?
Yeah, that's a good question. There are a couple of components here. First, I think that you need to educate the users, right? Typically, users have a working, like, for example, they're focusing their subject matter to a specific domain.
Mm-hmm.
So you either, if you know that what are the schemas that typically they using for their work, or you need to educate them about, if you have questions regarding to this specific domain, this is the channel that you want to work on. This is, provide a context, like this channel is focusing on sales for this product, and this channel is focusing on, and I feel like you can limit if there are two different line of business that are not related. You probably want to parse it and keep them separate and educate the user that this is only focusing on that, or and so on. Then there is the data governance component. I feel like it's super important, and if you want to make sure that this process will be as successful, or you want to help the model to be successful, you want to make sure that your fields, the naming, the tables namings, and the fields, the namings that you are using, is as intuitive as human will go and if you ask a question and data engineer look at the table names, it can understand where to look for, because that's how the model doesn't see the data. There is no connection between the model, the API, and the data. You just provide the fields names and their attributes. So if your fields are x1, x2, x3, or something like this, the model cannot make the connection. Then when you ask about between 22 to 23, you need to go for the year field.
Mm-hmm.
So I think there's like both sides need to, if they're not there, should force them to have more a good hygiene of like data governance. And on the other end, like you want to educate your user about how to use it.
Absolutely. Yeah, the way I was kind of designing my assignment to my students was kind of creating this two-step process wherein, depending on the question, you look up the schema and then use the schema to answer the question. So the end user, if there are like 17 different tables, so the end user need not know the schema for all these 17 tables, but based on the question, you kind of narrow down the scope to a specific set of tables which may have that information, and use that as a second step to basically generate a query associated with that to get back the answers.
I mean, generally, I think that there is some capability out there that you can do more complex stuff, that you even can let the LLM to decide by itself, like if you want to have like a multiple line of business and have multiple tables, the LLM could identify, but then as you add the complexity, you may expect that the accuracy will potentially drop.
Mm-hmm.
So as a strategy for, at least at the point that we are today, I think to enable the model success be higher, you most likely want to segregate it by separate between line of business and narrow the scope. You can still have like multiple schemas. If, for example, like a line business could have multiple schemas in the backend. And so like you in the function that I created, essentially it's I use DuckDB, but essentially you can send the the SQL that asks describe the table to Snowflake or anything else. You can replace it. And then I limit it to one table, but essentially you can generate multiple. Like you can have like add some loop component that if you have multiple tables, it will generate prompt for multiple tables.
Absolutely. So there's a question from Colin. Are there any techniques that come to mind to protect the database or other data sources from inefficient or potentially harmful in terms of denial of service or even data compromise or destruction queries? I know in the chat world, the human in the loop basically can potentially abstract out saying, I do not want to answer this question, or it violates the terms and conditions, stuff like that. So I'm wondering, is there a possibility to do something like that in here for, I do not want to get the private data from the master table or whatever it is?
Yeah, that's a good question. I think I'm not sure about it. I mean, I never thought about it. Let's start with this but there is for privacy. So in the process of when you're sending the query or the prompt to the OpenAI only see the names of the tables. It doesn't see the data. There should not be any connection, right? Mm-hmm. Between the data and the API. I read about a way that sometimes as a company, you don't want to disclose also the names of your tables and the fields, because essentially, like if you want to have it, that's like it's a double sword, right? If you want to LLM to understand, you need to provide more context about your table. And sometimes like there is some business knowledge maybe you don't want to share, because of privacy reasons. I know that people did some creativity like around it by setting like a mapping. Mm-hmm. And you just keep the context, but you change you have a mapping that, for example, if you have if you have a table of sales of, I know if you're a pharmaceutical company and you're selling different products, so you can replace it with instead of medicine, vegetables, right? So whenever a user create a prompt, it's essentially replacing the SQL, when you generate the SQL table about with the field names, it just map it to a different namings. Mm-hmm. And pass it back. So it's like encoding and decoding of your namings. But I don't know about a specific way to handle this case that, well, you want to protect that, you don't want to send like inefficient queries that will melt down your database. And that's another thing that I didn't think about it, but it's something worth to see. I'm sure there are like a data engineering tools that might be able to kill a query if it's consuming too much resources.
Absolutely. I can kind of envision a couple of other alternative use cases / extensions, if you will. One is, some sort of a query optimizer, if you will. Mm-hmm. Based on, you can write really inefficient queries. I mean, how many times have we kind of, written queries when we do joins and we realize like, oh, you could have written it a much more efficient way, right? Excuse me. So the hope is like, the LLM is generating the optimal query, but one thought is, what in case you have a specialized engine which could actually optimize your queries? So that is one possibility. But the other thing is, from a design perspective, you could potentially even think about like, hey, how can we, from a backend perspective, think about, I'm getting a lot of different kinds of queries. Can I create views? Can I create other data abstractions which could make, these kinds of queries much faster or much more efficient based on the kinds of queries I'm getting from end users? So there could be some analytical tools or extensions, but also in terms of query caching. If two people are asking for the same query,
exactly,
they're leveraging people's feedback, if you will. Like, hey, do you like the results from the query, or did it answer your question? And it's like validating the next time you could even, I don't know if it could be, I haven't tested it, but a prompt could be something like, well, hey, I'm asking for this kind of a question. Oh, by the way, for this kind of a question before, you gave me this kind of a query, which was considered to be accurate or which got a positive feedback from an end user. So I don't know if that would reinforce an optimal query execution or generation on the engine side.
And obviously there is also the process of, we talked before about fine tuning.
Mm-hmm.
And I saw like methods that people are, for example, they don't want to use the OpenAI as their main process, but because the OpenAI providing a good results, you can run like a basic questions, translate it in, and generate a training or tuning database from the OpenAI and apply it for, let's say, Llama or other open source LLM fine tuning, and then like you also can see like get feedback.
Yeah.
And as like someone that a data engineer to go and evaluate and see if there is additional tuning and then apply it on the model.
Absolutely. I was also kind of thinking, in the context of verification and validation, how could that even be incorporated as a part of the loop? Because now the end user is only getting the results. Is there a way to kind of do some kind of a query breakdown structure wherein, kind of a chain of thought, right? Like, hey, in order to get this particular result, I actually need to do these steps. And then show me your, query methodology, if you will, right? Query creation methodology, wherein you could basically do like a decomposition of the actual question and then basically structure it as like, here's how I got this result. Then I incorporated this join. Then I incorporated this particular filter. Then I did a group by, and that's how I got the result, which would potentially not only give you the results, but also enable the end user to validate that the query was actually doing in a thoughtful and logical way so that you could get back to those kinds of results. So I'm wondering if that could be an interesting extension to what you're doing. That way you are saying, how did you come up with the query? Or how did you come up with this particular query wherein you basically relay those steps?
Yeah, definitely. And I thought about, I thought like, how do you make it this process that like you need to, before you are actually exposing it to some users, you want to do some validation. So the process, like I know that's what most of the companies did, and including OpenAI, that you could provide feedback. So you get the results and ask you, does this results make sense to you? And if not, you can provide feedback. And I believe that if someone will build something, or people are, I think, already building some stuff like this, that they will have to do some process. It could be like a manual process that you're running some bunch of queries and you validate the results and see like what is the actual. So there is already, I know, data sets that are open for SQL that you can apply to do like a fine tuning some for general LLMs that are not code generator. But I think that we require, and I know there is also companies that are focusing on automate this process, like using like LLM on top of LLM to break down and make this process as much as automated. But I feel like you will, at this point, we still need the touch of someone with a domain knowledge about SQL to validate or give feedback about, does this process, is it, those are the right steps, or can we do it better?
Absolutely. So I think, we're getting to the end of the session. There's a huge possibility to kind of, change the world and the way we do things from a data perspective using these kinds of tools, especially when you're looking at, this notion of agents, specialized interaction between multiple kinds of APIs, but also the nature of how you could potentially design your data schemas, right? So, in the context of designing future schemas, right now we are thinking in the context of structured tables or unstructured data sources, and we are assuming that this is how the world is going to be there, and that's why we need to write queries in particular ways. So if that becomes flexible, wherein you could add new schemas and you could add new kinds of data sets, and now you can query those interactively, it opens up so many more possibilities. But also, as the tooling and the chain evolves, it also begs the question of what is going to be the role of database professionals in the future, especially with all the innovations happening in the GitHub copilots and other kinds of innovations where you can write code. So what is the role of a developer? And what is going to be the role of a database administrator or database professional? So it's a fun world to live in, but we gotta take one step at a time. I appreciate your insights and all the cool work you're doing, Rami. Good luck with everything, and definitely take a look at it. And if I have questions, I'll buzz you. As Rami mentioned, the code is available as a proof of concept on his website. For people who have registered on the Zoom session, we will be sending out the slides and also link to the code. Again, as we mentioned early on, next week on December the 14th, between 8:30 to 4:30, we are partnered with CFA Boston Society. And let me just share the screen. And we are doing a one-day workshop on ChatGPT, generative AI, and large language models. So you can go to the www.QuantUniversity.com to get more information about this course. It's a one-day course primarily geared towards financial professionals. So we're going to be using a bunch of different tools to build out various applications for large language models, particularly in finance. So if you're interested, take a look at it, and it's going to be available both in an on-site session in Boston at the CFA Boston offices, but also online over Zoom between 8:30 and 4:30 East Coast time. So hopefully this session was helpful, and you will hear more about future sessions as we send out more emails and we get more interesting talks to upgrade your knowledge in the various areas of LLMs, risk, and various aspects of data science. If you have any feedback for us, please send us a note. And I wish you a very happy holiday season, and I hope to see you soon in the next session of the QuantUniversity guest lecture series. Thank you again, Rami, for your time, and see you soon.
Thank you so much for the invite.
Take care. Bye-bye.
Bye.